This video contains the solutions for the parts number 1 on the 2009 AP Calculus BC free response portion of the AP test. Number 1, this is with calculator for some parts, and it will be required for part D. We want to find, let's see, we have a graph here of velocity versus time for Karen, who's riding her bicycle along a straight road. So basically rectilinear motion modeled by this function above. This is her velocity. So just to get an idea, she's going forward and then backward, and then her velocity is 0, not going anywhere, and then she's going forward, accelerating, constant velocity, decelerating but still going forward, and then back to velocity of 0. So this is going forward, this is going backward, that's not moving, it's going forward. Using the correct units, explain the meaning of, let's give part A. Find the acceleration of Karen's bicycle at time 7.5, right here, and indicate units of measure. Well, this is velocity. Acceleration is the slope of that. So let's see. Taking 2 points on that straight line, it looks like at time 7, the velocity is 0.3, and at time 8, the velocity is 0.2. So the slope here, y minus y over x minus x, 0.2 minus 0.3 over 8 minus 7 is negative 0.1 over 1. And what would the units be? Let's see. Our units here are minutes, and this is miles per minute. So if we're doing slope, minute, then we're talking about this rise over run, so that'd be miles per minute squared. So careful, if you're a big fan of SI units, it's not meters per second squared, it's miles per minute squared. Part B. Using the correct units, explain the meaning of the integral from 0 to 12 of the absolute value of v of t in terms of her trip, and find the value of that. Well, that's the area under this, the absolute value, and we know that that is how you find total distance traveled. So it's total distance in miles, right? That's our unit. And to find that, we just have to find the area. So let's find the area of all these pieces here. And remember, we're only doing positive area here. Well, this is 2 by 0.2, and then we have the triangle, so we take half of that. So 1/2 base times height, that would be an area of 0.2. This would have an area of 0.2. It's the same triangle underneath. This is 1 by 0.3. Half of that would be 0.15. This is a 1 by 0.3 rectangle, so that would be also, wait a second here, hold on, I think about that. This is 1 by 0.3. And it's a rectangle, not a triangle, so we don't need to take half of that, right? So each one of these blocks is 0.1, so that's 0.1, 0.1, and this would be 0.25 here. This would be 0.2, 0.2. So this area here in this rectangle is 0.6, and then this last bit here is a 1 by 0.2. That'd be 0.1. That's like half of one of those if you want. So let's add it all up. You can use your calculator, but this is 0.4. Those two give 0.4. It's 0.8, 1.1, 1.7, 1.8. Looks like the total area there. 1.8, and that's in miles, right? Total distance traveled is 1.8 miles. Shortly after leaving home, Karen realizes she left her calculus homework at home. Uh-oh. And she returns to get it. At what time does she return around and go back home? And give a reason for your answer. Well, it looks like here she's going forward 0.2 miles. We just figured that out in the context of part B. And here she's going backward for 2 miles. So it would stand to reason that at time 2, that's when she realized she was going forward, and then she went back. What time does she turn around? This looks like is where she started to slow down, and this is where she actually turned around. So at time equals 2 minutes, her velocity went from positive to negative. Went from positive velocity, right? This is the velocity function, so positive velocities, and then underneath to negative velocities. And then last, Larry also rides his bicycle along the straight road from home to school in 12 minutes. His velocity is modeled by this function, where also miles per minute. And we want to know who lives closer to school, Karen or Larry, and show the work that leads to your answer. Well, if we want to know how far they are away from school, we could find their displacements, right? That would negate the turning around part and just deal with this for Karen. So let's just do that first. So for Karen, the displacement, no absolute value this time, just v of t. So this time these would be positive and negative and cancel out. And since it's 0.4, this canceled this out. Those would cancel out the sum of all these areas. 1.4 miles from school. And then we could do the same thing for, what's his name, Larry. With the integral from 0 to 12 of his velocity, which is pi over 15 times the sine of pi over 12t. This is the calculator part. You don't want to be messing around with this without your calculator, though it might be doable. You still have this, so I don't think you're going to get anything very pleasant. And we need to compare it to 1.4, so in terms of pi isn't really going to help. And let's see, I did that in my calculator, and what did I get? I got about 1.6 miles. So let's recap what we did there and what those numbers mean. This is the displacement of Karen from time 0 to 12. This is at home, this is at school, so displacement is her distance from school. And same for Larry here, or maybe Lawrence, if you don't know him that well. And his displacement is 1.6 miles. So Larry, what did they ask? Closer? Who lives closer? Oops. So Karen lives closer. So that's a little bit more time she can spend doing her calculus homework rather than riding her bicycle to school.